Today our plan is to understand QoS with respect to FTD, quality of service. Now, before we get into that, I want to just show you where the QoS in traffic flow comes into picture. This is the place, access control policy. You see here, this one? Before it goes to the exit interface, before it goes out, that is where the QoS comes into picture. See, after getting into the packet, lot of things pre-filter happens, and then NAD happens. NAD also comes in the last, but decision is happening here, and then routing happens. After a lot of things, when traffic is about to go out of the egress interface, the access control policy will be checked. That is where QoS comes into picture. So the configuration of ACP and configuration of QoS looks similar because it is in this section. The GUI, it looks similar. Traffic coming from this zone, going to that zone. We used to do that in ACP. Isn't it? We write policy, right?
Yes.
Same kind of window only we'll have for QoS. The reason is it comes here. All right. Now let us go to QoS. Yeah, this is really true. People coming from routing background will have more to do in QoS. More in QoS. Like we used to write class map, match some traffic, and then policy map, and then we will set bandwidth or priority, rate limiting, all the stuff we used to do. At last, we'll attach the policy to the interface. And also, we do a lot of queuing methods in router. For example, fair queue we do, weighted fair queue we do, class-based weighted fair queue we do, and then priority queuing we do, and then LLQ, low latency queuing we do. But not all those queuing methods are supported or needed. First, I should say, not needed here. In FTD, those queuing methods are not needed. Not all of them, some are not needed. That's why it is not supported. It is not needed, so it is not available. So, I just want to tell you that here. When you do QoS on ASA firewall or a router, you do a lot of things there, but can't expect all of them here because this is a firewall. This firewall will first of all allow the packet to transit if only the policy allows. So it's not a normal router simply accept the packet ingress with the QoS and then egress with QoS. Here, firewall will not do the job. For example, you are boarding a flight. You may say, I have only 30 minutes. Let me go fast. No. The security people will not be hurry-burry. Whatever it takes, they will say, no, we want to scan you thoroughly. We don't care whether you take the flight or not. If you want to pass me, I will do my duty. Very strict. They will do the scanning thoroughly, bag scanning, passport verification, everything. And then only you can rush from there. From there you can run or you can roll or you can take that one small battery wagon. It's up to you. But this is security. Same procedure here. Increase policy, increase QoS, you no need here. Only egress is needed. Only when the firewall permits the traffic to enter, go out, only then the QoS comes into picture. For ingress, there is no need for QoS.
Yes, agree.
That's what I said. You may rush after scanning to the boarding gate, but before that, no rush.
Yeah.
Fine. Now let us read this.
Mm.
FTD QoS is policy based. See, we do have class map, policy map there, that is also policy based, but here the policy is not a simple policy. This is a policy which can take decision by looking very deep into the packet like application. So that is what they mean here when they say, hey, this is policy based. Even there also we have policy, but why they emphasize here in FTD we have policy based? This policy is something real policy based. And then, as I said, it is egress only. Only for those traffic, everything is green flag. For that, we are going to now follow the QoS. When I'm going to drop a packet, why should I apply QoS? The ingress, no.
Yeah.
No need of QoS.
Yeah.
Rate limiting, exactly. We do rate limiting. Why we need to do rate limiting? What is rate limiting? Yes, please.
No, I think it's like prioritizing the different class of traffic.
No problem. I'll tell you.
Oh.
Rate limit is like, because we are going to keep this firewall in the edge. Yeah, we are going to keep it in the edge, right? Because it is kept in the edge, the next hop is going to be ISP. Now, let us say ISP is granting you 200 MB megabits. 200 MB is what we subscribed. Now I think you got the answer. You cannot send too much because it's going to drop. So we limit the rate of flow so that it won't be simply go there and get dropped. We call it as shaping, but here they don't want to use the word shaping. Here in FTD, they use the word rate limit. So we set a limit. Hey, you can go only this much. That is one. And then another one, you are all entertainment websites, applications, YouTube. We can't allow more than 5 megabits. We have only totally 200 megabits for the internet. Now I cannot give all of them, so I'm going to set a limit for YouTube application. Only 5 meg. Yeah, and for all the company related traffics, I'm going to give 100 megabits. Rate limiting. And prioritization. What it is? Voice, video. Voice and video, they are very time sensitive. Whatever the congestion may happen, these traffics should never be slowed down or dropped. Which one? Voice and video. So I don't do rate limit there, I do prioritization there.
Okay.
So when congestion happen, FTP traffic may get dropped or slowed down. Any other traffic traffics will be going under some sort of disturbance, but the one which is going in priority queue, we call this priority queue. When you said prioritization, what happens is a queue gets created and that queue will never go down, and that queue will always be available for the traffic that you map into that queue. So we map voice and video in the queue. They will never shrink their bandwidth. They will always be available. That's why we call this prioritization or priority queue. Okay. So in FTD, quality of service is policy based, degrees
mm,
only, rate limit, and prioritization.
mm,
And as I showed you the picture, it is here.
mm,
It is before sending the traffic out. It
mm,
is tightly tied to access control rules
mm.
and pre-filter. Okay, where is pre-filter? Here it is. It should be somewhere here. Pre-filter will be having some star, I believe.
It's on the top, sir. On the top, next to the egress interface.
Ingress. This is
Yeah,
ingress. Traffic is entering in.
yeah, that's a pre-filter.
Pre-filter. Yes, yes,
Yeah.
yes. So this is received and this is transmit.
Mm, mm,
So we go back. So it is only after pre-filter and ACR, access control rule or access control policy ACP,
mm,
it is not interface MQC.
mm,
Modular quality of service, class of service,
mm,
MQC,
mm.
which is nothing but the three layered approach: class map, policy map, service policy map. Have you seen MQC?
Um, I'm not able to recall it, sir. Sorry.
I'll show you. Class map. In that we match a traffic. The traffic that is matched in access list 144 will be matched here in the class map. Do you see my screen? There is a match here in this class called voice.
Mm,
I
mm,
just named it as VOS,
mm,
and it is matching with an access list which I already wrote.
mm,
Like access list 145, 146 you see here, there is also
mm,
144 on top.
mm,
Hmm?
mm,
And then I am creating another class map called telnet that is
mm,
matching with this access list.
mm,
Traffic coming from any TCP going to this destination telnet. And then
mm,
another class map for ICMP ping.
mm, mm,
ICMP traffic I'm matching here. Now this is one step, the first step, classification.
mm,
And then what we do is we go to the policy map. You see I'm writing on policy map
mm,
here,
mm,
wherever some name I have given. And then I
mm,
call those class maps and I set DSCP value.
mm,
For voice class traffic, I'm saying EF, expedite forwarding. They are
mm,
highly prioritized.
mm,
EF
mm,
means.
mm,
And then for telnet, I'm setting assured forwarding 4, maybe
mm,
41. 4.
mm,
You have a lot of options.
mm.
You see,
I'm going
these
with
many options we
AF42.
have.
Mm, mm,
EF is expedite forwarding, the last one.
mm,
Next, we have set 42. Class, what's the other class? Pig. That's for pinging. Set DSCP AF, I don't know what value. 30. Yeah. So this is the second step. Now, what is the
mm,
policy
mm,
map name? Do you remember? Class map and policy map. At
mm,
last, you have to go and apply to the interface.
mm, mm,
See, the reason why I'm showing you this is what even you're going to do on the GUI.
mm, mm,
So now, two steps we have done.
mm,
These two steps are done in ACP,
mm.
access control policy, which I showed you here.
Yeah, yeah.
Inside that, you have QoS for the under the interface. You set
Mm,
QoS, and then you apply that into the interface. No, so that is what this step, which is I'm going to show you now.
mm,
Whatever whatever you need to apply the on the policy map, we apply to that. Do it.
mm, mm,
Interface F0/0. That's the inbound interface. You see. F00. In firewall, inbound is not supported. Here I am doing on router, so inbound
mm.
I can do.
Right.
I can attach here and say
Mm,
in input and say service policy.
mm,
input, it's coming in inbound, and the name is
mm,
wherever. That is all. That's all. Three-step approach. This is
mm,
what we call it as MQC,
mm,
right? So, um, but not interface MQC like router.
mm,
Meaning, in router we had three layered
mm,
approach: class
mm,
map, policy map, and service
mm,
policy map. That is
mm,
not the case here. Here we are doing everything in ACP, and then we are attaching to an interface. Finish. So that's
mm,
what
mm,
here I want to say. It is not
mm,
like router three level approach. It's just
mm,
go under ACP, finish all the configuration, attach to the interface.
mm,
Okay. So this is for those who come from routing background, uh,
mm, mm,
CLI background. It is very useful for them.
mm. Again, we as you applied it on the ingress, right, on the diagram. But here we have to do it on the egress,
Egress
right, sir?
interface, yeah,
Yes. Okay.
outbound interface, the one which
Okay.
is facing the service provider.
Yeah. Okay.
All right, so this is exactly the kind of topic that differentiates L2 firewall engineer. Okay, that's okay. We are all
Mm,
senior. We
mm,
understood these things.
mm,
Normal
mm,
engineers won't understand this.
mm, mm,
Okay, now this is what I was saying. FTD does not support all the QoS that you saw in router.
mm,
For
mm, mm,
example, class-based weighted fire queue and
mm,
low latency queue.
mm,
These two are not really necessary,
mm,
right? More this class-based is necessary only for ingress. When
mm,
you don't have ingress, then why you need this?
mm, mm,
This is a nice chart.
mm,
Rate limit per rule.
mm,
Yeah, we use it for each rule. For each policy, we say how much. Like I gave you example. YouTube 5 meg.
mm, mm,
Traffic prioritization. This is for voice and video. Strict priority
mm,
queue.
mm,
That will never suffer. Those traffic will never suffer.
mm.
Next
So
one.
that if for the traffic prioritization, it will use the full bandwidth, sir, like 200
No, no, no.
megabits.
For that
Okay.
also, we will set one bandwidth
Okay.
and we'll say if this traffic comes, this
Mm,
reservation, this much of bandwidth queue, and
mm,
it is strict queue, meaning that bandwidth will never be shared with any other uh, rule, any other service, any other
mm,
traffic.
mm,
But when you simply create a rate limit,
mm.
when the congestion happens, their bandwidth will be little bit shrinked,
Oh, okay. Got it, sir.
but this will
Okay.
never be shrinked. This bandwidth,
Mm,
this
mm.
queue will be
Okay.
always. That's why it is called strict priority queue.
Okay. Okay.
See the rate limit, um,
Mm,
we can also say in percentage.
mm,
YouTube,
mm,
2%. What does that
mm,
mean? In the available bandwidth, 2%.
mm,
So
mm, mm,
when you say 2%, it will not be the same bandwidth all the time,
mm. Right,
depending
sir.
on the availability.
Okay.
But
Yeah.
priority queue is not like that.
Mm,
In all circumstances, that bandwidth that you set will be always there.
mm, mm, mm.
That's the difference between rate limit and this traffic prioritization.
Okay.
Even in
Yeah.
the following page, I'm explaining this rate limit and
Mm,
traffic
mm.
prioritization.
Sure, sir.
Now, DSCP, I just showed you the
Yeah.
different probabilities in CLI. In GUI
Mm,
also, you have that AF, assured forwarding, 11, 31,
mm,
41, EF, expedite forwarding, all those,
mm,
different prioritization level. This is
mm,
also very important for FTD.
mm,
Per interface bandwidth control, it is only for egress. So these are
mm,
the things that are not supported in FTD.
mm, mm,
Queue tuning, which is nothing but the class-based vector file queue,
mm,
ingress
mm,
queuing, hierarchy queuing.
mm,
HQOS is there in high-end devices in the
mm,
motherboard itself. Hierarchical queue,
mm,
HQoS. It started with Huawei, according to my knowledge. Later, Cisco also started following this on the
mm.
motherboard. But in FTD, we don't have this.
Okay.
And the weighted fair queue, we don't have. Class-based weighted fair queue also we don't have.
Mm,
So, so FTD QoS is nothing but smart traffic policing. Why we say smart? Because applications can be
mm,
matched. And traffic policing, uh, what is the word policing here means? Setting the rate limit.
mm,
Is it going within that limit? Like police in traffic.
mm, mm,
If you go beyond that, they put ticket fine.
mm,
So smart traffic policing, priority queuing, DSCP rewrite. What is DSCP rewrite? See, in one device,
mm,
um, traffic is highly prioritized.
mm,
And you do not want to give the same priority level on the other device.
mm,
So what you do, you rewrite.
mm.
Uh, I'll repeat again if you are not understanding. Did you really understand?
I mean, if it is the same value, that will be a conflict, right? So,
No, 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 no. Not
mm,
like that. This is one device, this is another
mm,
device.
mm,
And this is another device. Now, let's say here the bandwidth is very low, 100
mm,
meg or
mm,
10 meg. Here you have enough of bandwidth. So what do you
mm,
do? In this router, for some of the traffic,
mm,
you do really stingy quality of service.
mm.
And for voice and video, you give, see, you got only 10 meg.
Yes.
So you say for voice and video, I'll give 4 meg
Mm,
priority queue.
mm,
And for all other traffic, the remaining, something like that you do.
mm, mm.
Now, I really don't want here also the same treatment. I have enough,
Right.
like a big pool of
Watch.
resource.
Yeah. Yeah.
Moreover, the traffic voice also comes from this direction, and
Mm,
they want to go this direction.
mm,
So if I
mm,
maintain that same priority level here, that
mm,
will be a problem.
mm,
So I want to give different priority level here.
mm.
I want to rewrite.
Okay.
Yeah. So some traffic which was poorly treated here, I want to
Mm,
treat here decent, not poor.
mm, mm. Okay.
So sometime I might have here given for some FTP traffic
Mm,
AF11, but
mm,
here I want to give AF41,
mm,
assured
mm,
forwarding 41. I
mm.
want to treat better way because I
Right.
have enough bandwidth here.
Yes. Yes.
So from here, when the traffic enters with the AF, before
Mm,
sending out in the FTD, what I do, I rewrite
mm,
to AF41 so that it
mm.
can have better treatment here.
Right. Okay.
That is
Yeah.
available. That
Yeah.
is possible in FTD. We can rewrite also.
Okay. But how do we capture that initial value, sir? How do we know that
Of course,
it does it?
it comes in the layer 3 header weight. You
Okay.
see, differentiated service code point,
Mm,
AF13.
mm.
Where do you see that? Internet
Yeah.
Protocol version 4, source 1.1. It's right in layer 3 header.
Layer 3. Right.
Every router, if it can read this, do you think firewall can't read this?
No, obviously it will read it. But as an administrator,
Yeah, we need to match. That is
uh,
QoS
uh,
policy.
mm,
We need to say, hey, have a look on this. We have to say that.
mm.
That we have to define it in the configuration.
Oh, okay. So if the firewall sees some value, maybe AF13 or something like
Huh.
that, so it automatically it will
Rewrite to
rewrite
AF43.
whatever the next available best thing
Whatever
it
I
can.
mentioned,
Oh, okay. Okay.
whatever I mentioned,
Mm,
it will rewrite. We have to mention.
mm, mm. Same way is also possible, right? So if
Yeah,
for
if it
example,
is
if
43,
first
I can
router,
rewrite to 13.
oh yeah, you can reduce it also or
Yeah, yeah.
increase. Okay,
That
okay.
depends on your topology design. Wherever
Mm-hmm.
bandwidth is less, that direction I'll rewrite to the lower value.
Mm-hmm.
Again,
Okay.
firewall engineers, they really don't have this knowledge. They don't do this type of QoS. Because we are from
Mm-hmm.
the good networking
Mm-hmm.
background, we are discussing on this.
Mm-hmm.
Even in the lab guide, you don't
Mm.
have this
But
deeper.
mm,
Yeah,
mm.
yeah. Tell me,
But
please.
to find out the value, one must do this packet capture to find whether it is need to be increased or decreased, and
Mm,
then we need to tell to the firewall, okay, please
engineer,
increase
yeah,
or
you need to
decrease.
tell the firewall engineer that I'm sending the traffic with this marking from the routers, and
Uh-huh.
whatever comes with these markings are very important for me.
Mm,
So
mm,
you do the
mm.
best when you send it out. So security
Okay.
engineer now he will write a policy, QoS policy, saying if
Mm,
you find any traffic with a DSCP so and so number,
mm,
you
mm,
rewrite to so and so number.
mm. Okay.
Yeah.
So is there any dashboard in the firewall where we can see
Yes.
the values
Yes. Yes.
for each application? So okay.
Yes. You do.
Okay. Okay. Then we don't need to depend on our network team to share those details,
Um,
correct?
correct. That is true. That is how it should work. But
Mm,
how many security engineers know QoS?
mm, mm,
So unless we tell, they will not know that there is something called AF13. First of all, they
mm,
will not know what is AF13.
mm,
So after you say AF13, they will go and find it. Ah, yeah, I can see. Okay, there is an option. There is a box where I can put the value for array. He will just put, but he don't know really know the. He don't know the meaning of it. Simply he
mm.
does.
Okay.
Okay, this is what I have
Sure.
seen in the real world. So
Yeah.
I'm saying
Yeah.
this. I'm not saying they don't know. They're not taught.
Mm,
They're focused only on security.
right.
Now, I used to say, whoever is coming to me to learn networking, I used
Mm,
to ask them, how good are you in networking? If they come for
mm,
security, I'll ask them,
mm,
how good are you in routing service provider? They'll say,
mm,
no, I don't want to learn that. I want to learn security. Then I will
mm,
ask them, you want to put a lock to a building and when there is no building or you don't understand the building.
mm.
When you do not know where to protect, how the network is,
Mm.
you say, I'm going
Yeah.
to put a lock.
Mm,
First of all,
mm,
you need to identify the opening in which the thief can enter. For that, you
mm.
need to understand the network, understand the building first.
Yes, sir.
So the
Yeah.
problem with security team is this: they come
Mm.
straight to security without knowledge of any routing protocol,
Yeah, yeah.
anything about QoS. That is
Correct.
where the lag of knowledge.
Mm,
That's why
mm.
they write very simple policy only, and then they say finished.
Yeah.
Not going this deep.
Yeah, yeah.
All right. So now, where QoS exists in FMC, okay,
Mm,
this is the path. You will be
mm.
doing the lab, right? Device QoS and
Yeah.
QoS policy,
Mm, mm,
right? So we create a QoS policy and we define the rule like traffic coming from which zone,
mm, mm,
going to which zone. Is it coming with any DSCP value? If it is coming, what DSCP value? Instead
mm,
of saying any, you should say it is coming with AF11.
mm,
Okay. Then outgoing, what should be the value? That is for rewriting I'm talking because we were talking about.
mm.
So all this
Yes.
comes in the second thing. And then you attach that to the interface. So there is a drop down menu where you map
Mm,
the interface.
right.
Simple. Three
Okay.
step. And where
Yeah.
you do these things, device, QoS policy.
Mm,
Now, traffic flow inside FTD. This is very important, correct?
mm.
That's the picture you have here,
Yeah, yes, sir. Yeah.
right? So traffic is entering in, pre-filter policy happens, and then
Mm,
access control policy, the QoS match happens, and
mm,
then it is applied. to the interface, egress
mm,
interface transmitter.
mm,
So QoS is applied after access control policy decision and before
mm,
the egress,
mm.
right?
Yeah.
So this picture I already showed you.
Mm, mm.
We'll be visiting this picture when we are into access control policy topic in
Okay,
detail.
sir.
Because
Yeah.
there is something called fast path.
Mm-hmm.
For fast path, the null QoS won't come.
Mm,
See, here is fast path.
mm, mm,
Traffic enters, takes the fast path, egress. But QoS is
mm,
here.
mm,
Now, what is fast path? For those traffic where the stateful entries are already there.
mm,
Already it went through a normal path. It
mm,
went through all the normal path. Now a
mm,
stateful table is updated.
mm, mm.
Second time again you no need to do.
Yeah.
It knows what QoS, what everything. Already it knows what ACP for that particular traffic.
Mm, mm,
So
mm.
it comes here and then out.
Yeah.
That's called fast path. We'll talk about those things a bit later.
Okay.
Type of QoS actions in FTD. We spoke about
Rate limit. Yes.
limit rate or rate
Mm,
limit, where we say you cannot exceed this much of
mm,
bandwidth.
mm,
We identify an application
mm,
or a user traffic and say, hey, this is the limit.
mm,
That's rate limit or limit rate. Next is set priority. This is for those time sensitive traffics like voice and video. We,
mm,
we create a queue which will
mm,
never shrink and which will have always that bandwidth that we set available
mm,
in all circumstances. The
mm.
bandwidth will be always there waiting.
Yeah.
Now, to say which one is more important, less important, we do marking. Based on the
Mm,
marking, for example, this is also a very big story that one should know.
mm,
I'll try this one.
mm,
Um, Even this enterprises, security service provider guys, enterprises guys also don't really know this, but they should know this.
mm, mm,
Uh, in DSCP,
mm,
differentiated service code point,
mm,
AF 41,
mm,
AF 43.
mm,
Now, let's say some packets are coming with the AF 41
mm,
and some are with 43, and now
mm,
congestion is happening.
mm,
When congestion is there, we have to drop some traffic to avoid congestion. Now,
mm,
which one to drop? Should I drop 41 or 43?
mm,
43 need to be dropped.
mm,
Okay, now what do you understand from this? 41 has got more weightage than 43.
mm,
Now, I'm having AF 11,
mm,
AF assured forwarding 31,
mm,
and now the congestion is happening.
mm,
I need to now drop some packet to
mm,
avoid congestion. Which
mm,
one should I drop? AF 11 or AF 31 or AF 41 or AF 43? This
mm.
time it is not AF 43. It is AF 11.
Oh.
Still congestion is happening. Which one to drop? 31. Still congestion is there. Which one to drop? 43. Now what do you understand from this? Within that 4, no?
Mm-hmm.
Bigger number is bad. But
Oh, okay.
between different number in the first place, this place,
Uh-huh. Okay.
smaller is bad.
Okay.
This knowledge, very few people have got in the networking
Okay.
world.
Yeah.
So this marking matters. According to this
Mm,
mark only the drop is going to be decided.
mm. Okay.
I'll show you one chart and then I will continue. So in the command line in the video I showed you, when I put question mark, you saw a lot of numbers like AF11, AF21, AF31, AF41. You saw that, right?
Yes, sir.
Okay.
Yes, sir. Yeah.
Now that has got a meaning.
Mm,
You see, low drop probability, high drop
mm,
probability.
mm,
In class in class 5, which means in this, if you compare,
mm,
this is high drop. This will get dropped first,
mm,
not this one. You have thousands of packets. Some are with this marking, some are with this marking, some are with this marking.
mm,
This is high drop probability. So this is the one which is going to get dropped first.
mm.
That you understood now?
Yes, sir.
Oh,
Yeah.
okay. Now let's go to the other vertical. I have packet marked with these markings.
Different classes. Okay.
In this case, this will get dropped first. This is low class,
Okay.
not this.
Okay.
After all the F11 is dropped, still if there is congestion,
Mm.
then F21.
21 will be dropped.
Okay, yeah, 21.
Oh, okay.
No, it will
Mm.
finish this direction. F11,
Oh, okay.
let's say you have F12, F12 will be dropped. Only after F12,
Ah.
F13 will be. No, sorry. That's. So if you consider this as well as this,
Mm-hmm.
if I consider this as well as this,
Mm.
so first getting dropped is this,
Mm.
and then this,
Mm.
and then only this.
Yes.
And if I have the second layer also, all three, then this will get dropped, and then this, and then this.
Yeah.
This is the
Got
order.
it.
So the
Yeah.
last one is only this. So this will never
Yeah.
get dropped. This will never get dropped.
Mm.
So 4 has got more weightage, that 41, 42, 43 and all heavy weightage.
Mm.
On top of all this, there is one more called expedite forwarding, EF.
Mm.
EF will never get dropped.
Mm.
EF is like 1010000.
Mm.
This is what? 4 plus 1, 5. This is only 4. 4. Yeah. So this will never get dropped. High prioritized. We call it as expedite forwarding. You got an idea, right?
Yes, sir. Yes, sir.
So that knowledge is needed for us to use DSCP in FTD.
Mm.
So only those who are real good networking engineer can also manage firewall. Straightly coming to firewall is not a good approach. Okay. So now there is also an option where you say trust DSCP. Meaning if a router is sending with AF41, in the FTD when I say trust, it will maintain the same.
Okay.
You
It
no need
will
to
not
mark. You no need to mark AF41. You are simply saying, I don't want to give you anything. I'm not giving you anything. You simply trust, meaning you just use the same QoS value that is already coming. You just trust it and use it. So the same way it will be treated even here. Between router and this firewall, you set a level of treatment. Same level of treatment is going to be continued. That is the meaning of trust DSCP. Maintain, don't change. So you will find like a radio button, trust DSCP.
Okay.
Put that this is what the meaning.
Okay.
Next. QoS.
And sorry, sir, and we can also see in the dashboard what DSAP value that packet is contained, right?
No, for that you need to go and filter one particular flow. Then only you will see in dashboard. Dashboard
Oh,
is for overall. No.
oh,
You asked me this question earlier. I said yes, but
yeah.
I don't want you to think that it is not possible. Answer
Okay.
is yes, it is possible, but you need to narrow down the search to particular flow or particular
Okay.
policy, QoS policy.
Okay.
When you go to a particular QoS policy, yes, you can see that.
Okay.
Not in the global dashboard, you can find that. You need to filter down and go to a. You will definitely see policies
Mm-hmm.
in the homepage in the dashboard.
Okay.
In that
Mm-hmm.
policy, when you go more granular,
Mm.
then you will find.
Okay. All right.
Right now, QoS rules matching criteria. First, see, as I said, it is same like ACP. We are going to learn ACP,
Mm.
but it is an easy one. You have done this in the previous
Mm.
lab when you were matching, you're creating zone. That is what ACP is.
Yes, sir.
Allow, deny. That is what ACP is.
Mm.
So same like ACP page, you will have a source zone,
Mm. Mm.
destination zone,
Mm.
source and destination IP.
Mm.
These all are there where in ACP.
Mm.
Again, you have here.
Mm.
Right? So this
Yes, sir.
is where we also attach QoS with it. Now, because you have visibility to the application,
Mm.
this is more powerful, more intelligent than the router.
Mm.
Routers can't match on YouTube traffic and set bandwidth. Not possible.
Mm.
Uh, Sorry, they are saying not possible. It is not. It is not possible at all. We do have
Mm.
regular expressions and do it, but it's very difficult part in the CLI.
Mm. Mm.
In ASA, we have done this, but it is not that easy like what you have here.
Mm.
Here you have predefined application ID. For YouTube, there is one ID. You simply use that. But in
Mm.
ASA firewall, we have to mention how YouTube will look like. We need to make
Mm.
ASA understand the YouTube application ID,
Mm.
and we can do it. Even in 2011 itself, I have done this on
Mm.
ASA firewall matching one particular application, but it was not that easy job.
Mm.
We need to first understand application and then find out the application ID, what to use,
Mm.
and then we were doing it.
Mm.
Okay, so here is the example. For example, if you want to set 2 megabits for YouTube, uh, um, but give more priority to WebEx,
Mm.
it is possible in FTD. Here it is said it is impossible on the N bar. N bar is nothing but network-based application recognition.
Mm.
See, we are talking about application.
Yeah.
In the early days itself, we used to do this N bar, means like 2009 and all, I remember. We used
Mm.
to do N bar on router. Only security operating system used to support N bar.
Mm.
Nowadays, many people do not know what is N bar.
Mm.
Network-based application recognition. We recognize an application
Mm.
and then we take some actions.
Mm. Mm.
But even in N bar, we don't have this type of fine-tune QoS.
Mm.
That's what they're saying.
Mm.
In N bar, we do match application, but not that easy like what you have in FTD.
Okay.
Right. Okay, this is a very nice one.
Mm.
Three main real world use case. Let's see one example. The first example: stop the user from eating bandwidth. How? You're matching Netflix, Facebook, YouTube, and setting the limit to
Mm.
5 meg, so that
Mm.
other important traffics will have better experience.
Mm. Mm.
These are bandwidth hunger applications, right? YouTube,
Mm.
oh,
Mm.
they take a lot of bandwidth. Sometimes people keep like 102 some pix level
Mm. Mm.
video quality level.
Mm.
They are going to consume a lot of Netflix. I don't know about
Mm.
Netflix, and my daughter knows it, my children knows,
Mm.
but I never used Netflix, so I do not know. But according to
Mm.
me, I think the quality of picture is very high. Resolution is high in Netflix. That's
Yes,
why
sir.
they're mentioning it here. And then
Mm.
Facebook. Facebook, why? Because you have a lot of live feeds
Yeah.
in Facebook is
Yes.
coming.
Yes.
When
Yeah.
you simply move the pages, lot of videos pops up, and
Mm. Mm. Yeah.
so mm. When I was small boy, it was like, how this is going to happen. You no need to change. You no need to turn the books pages, but you will
Mm.
read pages. Now that has become very common.
Mm.
See, if you take a physical book, to go to second page, you have to flip the page.
Mm.
But someone was telling me when I was small boy, you don't need to flip the page. Just you move your finger up. I
Mm.
don't know whether he came from time traveling. For
Mm.
2020, he might have come to 1980s.
Mm.
1980s, I heard some people were saying this. Those
Mm.
days, it was not at all impossible because we have never seen computer on those days. The
Mm.
early
Correct.
1980, like
Yeah.
1985, 86, someone
Mm.
was talking these things.
Mm.
Yeah, I was there sitting and listening to this.
Mm.
But now that is very common nowadays. Videos are going like pages.
Mm. Mm.
You do YouTube videos, thousands of
Mm.
videos by moving
Mm.
fingers.
Yeah.
On those days, movie theater only was showing movies. No
Yes, sir.
one can imagine that you have movies in your hand.
Yes, sir. Correct.
Very few rich people will have Doordarshan TV.
Yes, sir. Yes.
So now you see how much it is advanced.
Yeah.
I don't know what type of advancement, but it is somewhat,
Mm.
in a negative sense, advanced.
Mm.
Give priority to business application
Mm.
like WebEx, SIP. This is for voice, setting
Mm.
session,
Mm. Mm.
SIP protocol. See, when you are
Mm.
calling someone in WhatsApp,
Mm.
SIP will
Mm.
be ringing their phone.
Mm.
That's the use of SIP signaling. Actually, it will signal.
Mm.
Those are all important, right? Though it is very tiny, they are time sensitive. They are important for company. RTP is
Mm.
real time. That is also another voice.
Mm.
So these all are high priority traffic. So that's why we have given EF,
Okay.
expedite forwarding.
Mm. And we have only that 46
Yeah,
for EF, or we have
yeah.
any category?
No, there is no category for EF. I told you
Okay.
no 101,
Okay.
and then you will have 01 EF. That's it. This is EF,
Okay.
right? So this is for.
So, do we have like EF 46, 45,
No,
something
no,
like
no, no.
that?
That's what I'm saying. No,
Okay.
the answer is no.
Okay. All right.
EF is only one.
Okay, sir. Okay.
Only for assured forwarding, you have
Mm.
11, 12, 13, 14, and then 21, 22, 23, 24, 41.
Mm.
You saw that in the table. For
Mm.
EF, you don't have that. That's why you didn't see that in the table there.
Okay.
For EF, it's not available. Okay, I'll show you quickly. Only one line.
Yeah. Right.
You don't have much option for EF. Because it is highest priority, you cannot have many.
Okay.
If you have many, then how you can say highest?
Yeah. No, I just got confused with the number 446 on the bracket.
Oh, that
So,
one. That is the binary conversion.
oh, sorry. Okay.
Look at this.
Yeah, EF is the
I
last
want to
one. Yeah.
show you how it is 46. That is also an important thing many people do not know. Now, how is that 46? This doesn't look like 46. But
Yes, sir.
how
Yeah.
is that 46? Don't worry, I'm going to teach you.
Yeah.
I'm an expert in these things, so I'll talk a lot even if you don't like.
No worries.
Let's see 46, how you got
Yes,
46.
binary to decimal conversion.
No, it won't be 46. You convert and tell me how it is 46.
Oh, okay.
Show me 46. Wait, I'll help
Sorry,
you.
it's not, definitely not the decimal, but
I'll help you.
maybe.
You see, this is 0. So this is one place. Anyway, it is multiplied by 0, it's 0. This one, 2 multiplied by 1 is 2. Correct?
Yes,
This
sir.
is 4 multiplied by 1 is 4. This is 8 multiplied by 1 is 8. And this 16 multiplied by 0 is 0. 32 multiplied by 1 is 32. You add and see 40, 44, 46. What did you saw there?
46.
Oh, 46 you saw. Okay. Actually, it is 46, but it is not year 46. Okay, I'll give you an example. I'm trying to teach you something which that this has spoiled. They have written 46. They should not write like this. They have spoiled my teaching. I'm trying to teach you something. From here, let us see. You see this one. What is the value? Oh, okay, let us go with AF. What is written here? AF 42. Is
Yes,
this
sir.
42? Check whether it is 42 or something
2
else.
to the power 0, 2 to the power 1, 2 to the power 2, 2, 3, 4, 5. No, sir.
It is not 42. Is it 33? You see, it's not 33. It's not 33.
Yes, sir.
That's what I want to teach you now.
Okay.
So, you should not call it as year 46 because it is not year 46. This decimal equivalent may be 46, but it is not year 46. When this is not year 43, do you get 43 out of this? No.
No.
You don't get 43 out of this. Let me solve this one first, then I'll take you there to EF. How it is 4, 3, 1, 0, 0, 1, 1, 0. We cut like this. This is 4. We write 4 here.
Oh, okay.
And this 0 again, we cut it separate. Now this is 1 and this is 2. 2 plus 1 is 3. That's how you got 43. Now let's go to another example.
Oh.
Okay, this one. 1, 0, 0, 1, 0, 0. I ask you to cut this away. Cut this. What is the value here? 4. What is the value here? 2, right? This one.
2, yeah.
You got 42.
Oh, okay.
If you don't remove the 0 from here, then you may say here a 4. Is it matching there?
4, yeah.
It's not 42.
No.
Now let's see one more. 1, 0, 0, 0, 1, 0. What is this? 4. What is this? 1. You see 41. You understand?
Yes,
So if that is the case, how you should call, this is 5. Cut the 0 away. This is 3. No. 3. 2 plus 1.
Oh, sorry. Yeah, 3.
2 plus 1, 3. So it should be 53.
Yeah.
EF 53. Okay, so
Mm.
that's how the calculation goes.
Okay. Sure.
But for EF, you don't need to calculate and all. EF is the highest.
Mm.
Even the 46, you don't need to worry about, think about.
Okay. All right. Yeah.
Okay, now the next is use cases we are seeing. Why we need quality of service. The third use case, the guest networks. They are just guests. They're coming maybe for some discussion, business
Mm.
proposal. Uh, no need to give too much of importance for them because
Mm.
our business is going on inside. They need more priority. So we set some limit here, 10 meg only.
Mm.
Okay, so those are the three example use cases. First example,
Mm.
based on the application. If it is very
Mm.
important application, we give more, less important for other. Uh,
Mm.
see, we have given high weightage for this. And then for the guest, we have said this.
Mm.
Okay, what is the difference between priority and rate limit? I told you the
Yeah.
priority
Mm.
is um, it is it is highly prioritized.
Mm.
Voice and video never drop never happens. But
Mm.
for rate limit, when it exceeds, it will drop because
Yeah.
you set a limit of bandwidth.
Mm.
Here you don't deal with bandwidth. You say, hey, I want this queue to be always there available, and this much bandwidth fixed always. Here the bandwidth will vary depending on the availability. Control of
Yeah.
bandwidth is here.
Mm.
Here, free to use as much as you want, voice and video. I want you to be
Mm.
safe and sound. I give you full control. Take it as much as you want. Whatever you leave, only then the others can use. And that's the
Mm.
attitude.
Mm.
So here, this is the high Q preferred.
Mm.
This is not that way.
Yeah.
Alright. So you always combine the priority plus the rate limit. Priority is for the voice and video. Rate limit is for
Mm.
the rest of the traffic. You should not call it as
Mm.
junk traffic. Rest of the
Mm.
traffic.
Yeah.
About the DSCP marking, I think we have seen enough. We do
Yes. Yes.
DSCP marking whenever you send to ISP. We want to set some limit and send. Even inside the switching routing
Mm.
SD-WAN, we do DSCP.
Mm. Mm.
Example, you match RTP, real-time protocol, which is a voice traffic, and you
Mm.
set what? EF, which is a high priority.
Expert. Mm.
At last, we need to attach to the interface. How do you attach to the interface? Device manager interface, and
Mm.
then go to the QA section. You just create the
Mm.
policy on the top, no?
Mm.
That will appear there in the drop-down menu.
Mm.
Map it
Yes,
and
sir.
apply it. Oof.
Yeah.
Easy, right?
Okay.
Okay. Now the order of QoS rule means,
Mm.
how do we configure? See, order matters. Whatever is in the
Mm.
top will be given first.
Yeah.
So give high priority to the voice and video, and then the business application, and then the guest, and then the Facebook and Netflix and blah blah, and then the remaining.
Mm.
This is
Mm.
the sequence. Sequence matters because it is
Okay.
top-down match.
Mm.
I think all the important steps are over. Okay, now here,
Sure.
the difference between pre-filter, ACP, and QoS.
Mm.
Fast path is not applicable for QoS, even for ACP. What is fast path? For the traffic where the statefulness is already there.
Mm.
Firewall
Mm.
knows how to deal with it, what QoS to do, whether to allow
Yeah.
or not. It knows because it has already gone through ACP.
Mm.
Some sessions are not the first time.
Mm.
The first time should go through ACP,
Mm.
first time traffic. If session
Yeah.
is already available,
Mm.
then it will go in fast path. For fast path, only pre-filtering. You saw the picture, right?
Mm.
It goes through the
Yes, sir.
pre-filtering and then goes out egress. Ingress, pre-filter, egress. In the pre-filter, you already have the stateful table.
Mm.
So no ACP, no QoS. It doesn't mean that the traffics are not going through QoS. They're already known to the pre-filter. Pre-filter knows how to deal with it.
Mm.
Security decision,
Mm.
If you are focusing on security decision, then it has to go through the access control policy. That is the place where decisions are made. But that is not QoS again. You are focusing only on security. Only when it comes to traffic control, QoS. All right. So a use case like bypass pre-filtering allowed in high control. I think it's well understood in the previous thing. Okay, lab scenario. You have the lab. Okay, here let's see what lab scenario I have here. For RTP, set this much value because it's voice. SIP. If and for Zoom and blah blah, set high priority. Yes, it's repeating again, with a different value.
Right.
Okay, if you're planning to verify in the CLI, these are the commands.
Okay.
In the FMC, go to analysis, connections, under the QoS column, you can go and verify that you are asking whether can I see the DSCP value. This is the place. You see the analysis tab, click on go to connections and click on QoS. All right, common mistakes and all, I think, jitter and all. Okay, let's discuss. What is the common, we have come this far, let's finish this. What are the mistakes? Sometimes they miss to attach, they fail to attach the interface. It's of no use.
Yes, sir.
After doing all the configuration, if you can't give it to the interface, then what action, no effect will be there. That is one mistake.
Or sending in a different interface not
Yeah,
meant
that
for
also will be a problem. Putting junk rule on the top. See that sequence matters I showed you. First you put what on the top? Voice. So if you put junk rule on the top, that will be processed first and voice will suffer. Next mistake they will do is only rate limit, they are not using priority queue. No, we should use priority and then rate limit. Rate limit is for the other traffics, priority is for the time sensitive traffics. So these are the common mistakes engineer would do. Okay, there is another one. Forget DSCP marking. So if you don't put DSCP marking, then the ISP router will not know which one is important and which one is. If ISP router need to drop, then they will drop any traffic, any packet. If you set some marking, then ISP router will drop only the low priority traffic. So we have to.
But again, sir, for that, the ISP also should be in agreement with us to have the
ISP has
QoS.
already told you, 200 meg, whatever you want, you send in 200 meg limit. But unfortunately, you are sending more. Assume you didn't limit. They are saying you send it to up to 200 meg. That is the committed information rate. But you did not keep a control over sending. Some people do that. They think that if I send more, if I set high priority, I can use more bandwidth. Not at all possible. When you set a DSCP value, when you mark DSCP and send, if you send within 200 meg, no problem. But if you send more than 200 meg, ISP have to drop. They will randomly drop now if you don't have marking.
Okay.
Then sometimes important traffic also will get dropped. With marking, they don't do random drop. They drop only those with low marking values. Okay, the difference between ASA QoS and FTD QoS. In ASA, I showed you, class map policy map. Here we have ACP, GUBI, not CLI. Here it is port based, here it is application based, where YouTube, Facebook. Here we use port numbers. This is CLI, very heavy. This is FMC, easy. This is less intelligent because it cannot go deep into applications. This is more intelligent. Golden rule. FTD QoS is firewall aware, user aware, application aware. Not interface QoS like router. See, it doesn't mean that we should not apply on the interface. We have to apply on the interface, but it
Mm.
is aware of whatever the firewall can do, it can do, plus user aware and application.
Mm.
Okay, interview questions. So this is about quality of service in FTD. What is left
Okay.
is you when you get the chance to do the lab, most probably by day after tomorrow, right? You will
Yeah.
have your lab again. So
Okay.
try these things with understanding. Now you can do. You're not going to simply do what they are showing you to do.
Yeah.
You
Sure.
first
Sure.
do that one. Along with it, you try all these things that you have learned.
Yeah.
I also showed you where to go and what to do, the path and all device, QoS, and then to verify, I showed you go to the manager. Where is the path? For verification to analyze, I showed the path here, device management, interface, and QoS. So on the
Sure.
dashboard, I showed you one path. Okay, here. Mm, mm, no, not this one. Okay, you have this the video. So
Okay.
go through this video before you do that lab, and then
Okay.
you will